this video, we will begin looking at simplifying exponents using the quotient rule. To investigate the quotient rule, we will consider the expression a to the fifth over a cubed. A to the fifth in the numerator means we are multiplying 5 a's together. A to the third in the denominator means we are multiplying 3 a's together. By simplifying and dividing out the common factors, we find that the only ones left are the a squared in the numerator. We started with 5 a's and divided out 3's. To find out how many are left, we can simply subtract 5 minus 3 to get the 2. This gives us the quotient rule. If we have the same base in the numerator and denominator, we will simply subtract the exponents, a to the m minus n, to simplify our expression. With the quotient rule, we subtract the exponents. Let's take a look at a few examples where we can see this quotient rule work out. In this first problem, we see a to the seventh over an a third. Again, we will subtract those exponents, 7 minus 3, to get a to the fourth power. With the b's, recalling that with no exponent we assume there is a 1, when we subtract 2 minus the 1, we get b to the first. This first power is not really necessary, because we always assume there is a 1 if nothing is written. Our simplified solution is a to the fourth, b. Let's try one more example. In this problem, we see we have numbers and variables. We simplify the numbers as always, being careful not to use an exponent property on a base. 8 and 6 are not exponents. We will divide or reduce them like we always have. Both are divisible by 2, giving us 4 over 3. On the m's, we will subtract the exponents. 7 minus 5 gives us m squared. Because the answer is positive, we leave the m squared in the numerator. Also subtracting the n's. Exponents, 4 minus 1, to get n to the third power. And this becomes our final solution, 4m squared n cubed over 3. The quotient rule asks us to subtract exponents when simplifying our expressions.